Yeah, there's a weird dimension. I'm not sure whether, like, I'm certainly doing stuff in practice. Oh, this is the wrong screen. See, this is where the experience might not translate directly. Use mirror. Does this change something?
Yeah.
Wonderful. All right. Yeah. So my years in academia are quite a few years behind me, and I've already made it. I've just made it to bachelor's degree. I was too keen to going back into actually building apps myself again, and this is what I've been luckily doing for the past few years. Particularly over the past 2 or 3 years, I've been building a local first, not quite local first yet, music app. So yeah, I'm Johannes Schickling. I'm based in Berlin. Before working on this, before being introduced also to local first, I was trying to help developers work more happily with databases, where I've been building a tool and company called Prisma. But right now I'm pretty focused on local first and doing also a bit of open source R&D besides that. Overtone is the app where I've collected most of my experience actually building local first software or aspiring local first software with, since the caveat to Overtone right now is that it's technically still local only. Hopefully over the next year we'll make the jump to being fully collaborative and syncing, and therefore local first. But it also feels like quite refreshing, having spent, I guess, like the last 10 years all thinking about cloud architectures, to now really think, oh, like we can actually push things forward quite a lot, just like in that local context. So this is where I've spent my innovation tokens, to borrow that term. And so really trying to make the app as fast as possible, as nice as possible to use. Overtone as an app itself, you can think of in the same ways we can choose between different mail clients, and wherever our email servers live, we don't have the same luxury for music. I want to change that, and I want to give you a very premium music client that you can use with whatever music source you're using, whether it's SoundCloud or Spotify or whatever the pirate flag means. Thanks to Peter for that great suggestion. I keep pushing back the time for access by another half a year whenever I give a talk, but hopefully this time around this is more accurate. I just want to give you a quick proof for what I've been working on is actually does exist and does work. The screen resolution is a bit different than I expected, but so this is Overtone. Typically on my screen this says 120 FPS, but I guess not quite on this setup. This is all driven by a state management solution called Riffle, which is based on the previous collaboration with Jeffrey and Nicholas. So this can, as you'd expect from a music app, actually play back music. This right here has like access to all of my Spotify playlists. Navigating between here is all typically 120 FPS. I can like have this sort of Command K traversal. I can go to different artists. So kind of what you'd expect from a music app. So just as reference and to prove that what I'm talking about is actually backed by building a real app. So particularly, so the talk, the title of the talk was sharing some of my lessons. I wanted to share more lessons, and you all are invited to approach me afterwards for other things I might have learned along the way. I needed to condense what I'm talking a bit more, and so I'm just talking about client-side management. This, I think, is compared to what we've heard before today, I think nicely complementary to a lot of the syncing things, etc. No security, no privacy. This is just about how you get the best possible client state management setup that I could think of. And we've heard some suffering, from using Redux today, and there's also other alternatives such as MobX, etc. I've used those technologies in the past extensively, and sure, you can build simple, medium, and sometimes even sophisticated apps with it, but I wanted to rub an actual database on it, and that was also the core idea of where Jeffrey, Nicholas, and I started our collaboration. Since Jeffrey and Nicholas, I think Jeffrey spoke about this at last year's PLF, where the idea was basically, hey, can we use this great technology SQLite, and can we use that as an actual state management facility for a real-time app, and for like ad reactivity, etc. So this is what Riffle is all about, and I was kind of a partner to this project by building an actual app on it. So, and we've been facing an kind of existential question that almost plagued us for the entire duration of the project, and we weren't quite sure, like, are we making the right call here or not? So if you're actually looking for how you use SQLite with Wasm kind of officially, this is from the Google Chrome blog, where they tell you this is how you use SQLite in browser apps, which is a worker-based API. So they seem to suggest one way. Nicholas, who's been working on like SQLite-based systems at Apple before, I think he and Jeffrey came up with a different idea. What if we actually put the SQLite database in the main thread? So we've been going back and forth on this, and so we came up with some trade-offs. So if you're using SQLite on a worker thread, that felt like the more conservative bet. Sure, you have an async API, so whenever you want to query some data, you need to wait from your main thread to get a message back from your worker thread. But on the other hand, you can't block the main thread, so whatever slow queries you're making, the main thread is not harmed by that. But you do have that latency of like crossing the web worker. You also have more like a higher database size that you can work with, since it's basically rather bound to whatever the browser allows you or your file system allows you. And data is typically pretty safe, persisted on disk, whereas on the main thread, it feels a lot more gnarly. The data has to fit in memory or whatever the browser tabs gives you. It can block the UI, so if you make a slow query, the user will suffer. But there's a lot you get in return. So you get a synchronous API, which simplifies things a lot, and you basically have no latency. So we've been thinking about this. We wanted to live in a world where we have no spinners. We wanted to, or this was also the kind of the dream for me. If we get a database, typically in a cloud context, I've worked with a database in a kind of like having async APIs, but here, coming from a JavaScript world where Redux, etc., is all synchronous, I wanted to have the cake and eat it too. So I wanted to have a database, but synchronous APIs. So we took the red pill. The benefits are great. We're now 2 years in and been like sometimes kind of doubting, oh, was this the right call? And then like a month later, yes, was the right call. And it's those two things are, I think, really the main things for me. Is like it's much simpler to program in. So just by like this code example, for example, if you query some data, you have some tasks and off status. Now you have like here, even like locally in your UI state, kind of a distributed system that you need to deal with. And this is just like a teeny tiny example. This ruins like all the fun of building an app for me. So this is kind of table stakes right now for me. That's you have sync API sync query responses. It removes so much what I'd consider accidental complexity if you look at most apps today. And it's also if you like tame the queries, you get some really great performance out of it. So this is what made it all worth it. But there were challenges. So I think the number one is, given that we're now running on the main thread, you can think about that similar to how you build a game. Like on a game, you also you have a frame budget, etc. So you try to do as much as possible in a frame, but not too much, since then the game starts to lag. So you gotta try to make it as efficient as possible, and that was a lot of work. Also, the data size limit, in my experience, rather a theoretical problem. We haven't hit that yet. And also just implementing all of this. So I want to share a few more words about that. So frame drops, not going to lie, the app still sometimes drops frames. We know what levers we can use to avoid that. We've already come a really long way. But this is that's pretty tough. And while working on this, I also realized that most web apps we use today, including Slack and Discord, etc., they drop frames all the time. And so I'm feeling already pretty proud of how far we've come, and knowing what you can do there to improve things. And yeah, it's mostly avoiding slow queries, avoiding not doing too many queries all at once. And when you've done that as a baseline, then you can also make things faster by caching where it's possible, doing things like incremental view maintenance. We also have a very great collaboration going on with a person, Matt Wanlaw, who is working on some automatic incremental view maintenance things, also super interesting. And ultimately, given that the app still needs to do a bunch of work that needs to happen at some point, I needed to build a app-level task scheduling thing, which is, I think, fairly uncommon in web apps. But this is basically when I want to run some piece of code, I need to slice it up, yield once in a while back to the render thread, that it can handle the user's interactions, so that it doesn't result in a dropped frame or multiple dropped frames. And doing that in the web is kind of tricky, but we figured that out, and that's paying off big time, and prioritizing work that needs to happen or that you can cancel again. So that's quite the undertaking, but it's been paying off a lot. Then another, I think, more of a conceptual challenge. We haven't hit that yet for Overtone. So far for Overtone, all the metadata that we've been working with has been fitting into whatever device we've been testing it on. So for in that domain, 100,000 tracks, for example, we're roughly correlating with 100 megabytes of the database size. And let's say your app is doing something completely else, where you really deal with hundreds of millions of rows. I think this is where you could also partition the data, use smaller SQLite databases and use the attach feature. So yeah, we haven't crossed that bridge yet, but I'm feeling optimistic that there are also ways around that. Or you could have a hybrid approach where most of your UI state is in the main thread, and then some slower data could be on a worker thread. But yeah, if anyone is following a similar path and has run into those sort of limitations, I'd be very interested to talk about that. And then in terms of implementation, yeah, we just, first of all, we dared to take the red pill. I'm not sure whether too many other people have followed a similar approach. So lots of pioneering work, lots of self-doubt whether this is the right path. Efficiency was also all along a pretty big problem. So that's kind of the other side of the performance coin. If you might be able to build it in the app in a way that is all runs 60 FPS or 100 FPS, but that could still mean that you're using up the budget of every frame, and you waste a lot of CPU and makes your battery drain. So I had hot laps a lot, particularly when I was traveling. So also trying to maximize efficiency. By now, I think it's in a good state. We need to come up with a solution for persistence. So in a way, we actually took the red pill primarily, and then also the blue pill for persistence. So we also run additionally a web worker, which is just there for persistence. So we kind of mirror the write calls to that. You could also think of other mechanisms. And we layered a reactivity solution on top of it based on Adapton, which allows us to, when we write to the SQLite database, that the corresponding React component is updating. And yeah, that was mostly it. A quick shout out. We're going to start a local first podcast that might be happening at some point. And I'm not sure how I'm doing in terms of time, but I'd rather get into the questions.
Thank you. My 5-second hot take of this talk. Deciding between what Google tells you to do and the thing that looks easy, take the thing that looks easy is probably better.
So, Johannes, many people have told me that it should be possible to have a CRDT running in a database. Matt Tanteman is building Vulkan, which is a SQLite CRDT. It seems in principle that it should be possible to put like AutoMerge or YJS and have it syncing into SQLite. And as the number one person I know who is really into web stuff, database stuff, and local first stuff, I'm just wondering when you're going to start work on that.
I'm glad you asked the question when I'm going to start working on it, and not like what is my take on it, since I will start working on it, but I don't know my take yet. So I'll give you an update in the months to come. But I'm starting to pick up the conversation. Also, Walter is here from Electric SQL, so we're just exploring that with whoever has thoughts on that, and yeah, hopefully I have a take on that soon.
You talked about how async programming takes the fun out of programming, but splitting the work up into these small chunks would seem to take the fun out as well. But is it really more fun that way than the other way?
Fair. I think it depends. In building a UI, I think the things you do should be all very small. And so this is all totally possible to follow this architecture if you don't accidentally do a whole lot of unnecessary work. And I'm kind of switching between hats. I'm either wearing the blissful application developer hat who's building a feature and has a lot of fun and doesn't think about that at all. Or then once in a while I do, as an application developer, recognize, oh, there's some things that are slow, and then I go into, I've built a lot of dev tools around that for observability. Then I try to figure out, okay, what is this time the reason for slowness? Then I switch into library builder mode, and then I realize, oh, there's all of this entire category of unnecessary work that's happening, and I can remove that, oversimplify it, and tell my application developer persona hey, it's faster now, but nothing has changed for you, and then it's a lot of fun. But yeah, I think I would say broadly this applies for UI apps. This is where it should all as a render loop, nothing there should take very long, and then the things that are inherently maybe taking a bit longer, then it's also kind of fun to think about that. And then I would rather say, oh, can this, maybe as another big thing to lean on there, does it need to happen on the main thread? If it doesn't need to happen on the main thread, I'm very happy to put it on a web worker and then async all the way. But for the things that need to happen on the main thread, this is where a sync API makes things a lot easier.
Okay, thanks.
If just someone could, imagine a programming language where multi-threading was easy. I do have one more question. So you do use SQLite, right? Which is pretty complete implementation of the SQL standard, which allows a lot of complex queries. But you said you kind of try to use simple queries for performance reasons. So what do you say is the trade-off level? How much do you get from SQL as a complex query language? How necessary is that? How much does it help with the application?
Right. So why I wanted to have something like SQLite as opposed to something like MobX, etc., is because I want to, knowing that Overtone already is a fairly complex app and will only grow more complex, one thing that I need to lean on a lot for that complexity is data models. And I didn't have a clue like 2 years ago what the data model would look like a year from now, like a year ago, and like even less today. And I'm pretty sure that today I don't know what it will look like in a year or 2 years from now. So my data models constantly evolve, and being able to decouple the way how I think about my write models and the read models is very liberating. And this way I can basically, I'm following also kind of like a event-oriented architecture, not quite event sourcing, but ish, is also evolving. So this way I can think about my event log as the write model, and wake up tomorrow, rethink my view model entirely, refactor it, rehydrate, and do very sophisticated queries on that. Whereas like with MobX, I'd need to like rebuild everything. So a database gives me quite a lot of power that I
Do you
use.
store both the event log and the hydrated UI state in the SQLite database, and how do they relate?
So technically, yes, the event log, it lives on a different thread though, but that doesn't matter. Like that's could also be binary encoded into whatever like OPFS.
So it's mainly the application
Yeah.
state that
Yeah,
lives
exactly.
in the database. Right. Any more questions from the audience? Otherwise, we have a talk on time, which is great. So let's thank the speaker again.